Hello and good morning everyone, and welcome to the DigitalMETDialogue session 1. Today we'll be focusing on open science and open data. I am Carlo Bontempo. I am the director of the Copernicus Climate Change Service, and so the topic of open data and open science is very close to my heart. The license of Copernicus effectively offers open and unrestricted access to data, so it's really a topic I'm very passionate about. There is also another reason why I think this session today is very timely, and is what has happened in the last few months. The COVID outbreak and the pandemic that has affected all our lives has also demonstrated the value of having good access to traceable data and good access to open science. This is also the reason why we cannot be all together in the nice venue in Slovakia, and I would like to thank the Slovakian host for all the work they've done in trying to prepare the event. Unfortunately, we needed to cancel because of the pandemic, and so we decided to mark the day when the EMS conference would have taken place with these dialogues. So we have today a very excellent panel joining me in this discussion. So Wilco Hazeleger will discuss about the principle of open data and open science. Then Peter Kalverla will be looking into the details of and some good practice in terms of sharing data and sharing codes and what is normally done and now can be done. And finally, Gerhard Adrian will provide a WMO perspective, so what WMO is doing in terms of facilitating open data and open science. So before we start, just a few information about the interface and how it works. So this is quite a standard teleconference interface. So you can increase the size of the screen through the full screen button. You have a chat windows on the side, and this, as you will see, is quite important. This can be popped out if you want, but it's also a way of asking questions in the chat. There is the handout, and the handout, which is another tab on the right, provide the information about the talk, so all the abstract can be found there. Some quick housekeeping rules. So after each presentation, we will take a couple of questions that are specific to the presentation. The other question will be considered during the general discussion at the end, after 3 speakers have finished. The chat I was mentioning before is the way you can use to ask questions to the presenters. The question you type in the chat will be seen by the presenter and by myself, but it won't be visible. They won't be visible to everyone. We'll try to pick as many questions as possible and bring them to the attention of the speaker, either at the end of the talk or for the panel discussion. But given that we have a finite amount of time, it's not guaranteed that we'll manage to pick up every single question. Yeah, so I think that's pretty much it. So let me just go back to our panel, and let me introduce our first panelist of today. So Wilco Hazeleger is the Dean of the Faculty of Geosciences at Utrecht University and Professor of Climate System Science at the same university. Wilco studied meteorology at Wageningen University and at Reading University, and obtained his PhD in 1999 in physical oceanography from Utrecht University. After his PhD, he worked at Columbia University in New York and at KNMI on climate dynamics, climate scenarios, and the development of global Earth system models, in particular EC-Earth. He was also professor in climate dynamics at Wageningen University, and he served as the director of the Netherlands eScience Center from 2014 to mid-2019. Wilco has also co-authored over 100 peer-reviewed papers and has served on a number of committees on climate research, meteorology, data science, and open science. So without further ado, let me give the floor to Wilco. Wilco, the floor is yours.
Thank you very much, Carlo, our chairman of today. It's a pleasure to talk to you about open science. We have to do it in this way. I'm at Utrecht University right now, and I'm glad I can address you at least in this online way. And as mentioned by Carlo, I have a background in meteorology and climate research, and for the past few years, I've been working at in the digital area and approached open science from that point of view. But recently, more again from the scientific point of view, but also from the institutional point of view. Being involved with large contracts with the publishers, for instance, on science. But let me start with our own field, at least my field. And let me start with a well-known picture which was presented in the special report on extremes quite a while ago, and which has been, I guess, quite influential in looking at our field. In particular for climate research, that if you study climate research, it's not only often about weather and climate events, in particular if you apply it. So it's not only about the physics or about the forecasting of the physics, but also of the exposure. Think about where people live, think about our infrastructure, think about our financial governance, for instance. These are as important when we want to consider, for instance, disaster risk, and of course the vulnerability of our society. Of course, this has been very true and relevant also for meteorology already for a long time, that the way we use our NWP products is really much wider, and you need to consider many more fields than just our own physical weather and climate research. So it became very interdisciplinary and of large societal relevance, and that means many streams of information and data come together, and that means that open data and sharing data and interoperability of data is actually to a large advantage to our field. So open science, what is it? Well, there are many definitions around. If you go to the web, or if you go to different organizations that really advance open science, there are many definitions, but I like this approach. It's really about conducting science in a way that it fosters collaboration, which is needed in this interdisciplinary world. And it allows others to contribute to the scientific process. That includes even the citizens, and reuse its outcome. And if you look at it a bit more wider, then it's really about sharing scientific knowledge in its widest sense. And if you think about what I just said about meteorology and climate research, it actually fits our kind of research really, really well. But there are also other issues why we care. Those may be negative incentives. One of them is this one. It's about reproducibility of our science. This is about a picture from a paper published 4 years ago in Nature, where 1,600 researchers were surveyed and asked about reproducibility and the replicability of their research. And perhaps shockingly, or perhaps not so shockingly if you've been in research for a while, more than 50% said there's a significant crisis. And this is very much true also for the earth sciences, geosciences, climate research, etc. And this is a major issue, I think, because the trust in science should be really, really big. If we want to use scientific information, also in the current pandemic crisis, we need to have trust in our work. And that means the work needs to be reproducible, or even replicable, if you like. So this is another reason why we should really share more of our data, our workflows, and our knowledge. And I had to think a bit about this as well. It's from an event that happened more than 10 years ago now, ClimateGate. I guess many of you have heard about it. Actually, it was about hacking of emails first of scientists, which was probably very illegal, but also the practice of science came up. And this is a statement from a hearing that says it's not standard practice in climate science to publish raw data and computer code in academic paper. However, climate science is a matter of great importance, and the quality of the science should be irreproachable. We therefore consider that climate scientists should take steps to make available all the data that support their work, including raw data, and the full methodological workings, including computer codes. This is a great statement, I think, that came out of the House of Commons, and it's very much true even today. And I think we made advances, but there's still a lot of work to do in our field to go forward. So what is open science about? I already said that there are many different aspects to it. One of them is open access. That's already been discussed a lot, and actually we make big advances in that. Open review as well. The review itself, perhaps also the reviewer information. Open data for sure. Open software. Open infrastructure. Can we use computational infrastructures widely, or other kind of observing infrastructures? Open education, and perhaps in the wider sense, open information. So there are many aspects to open science that can be considered, and that are actually considered in many different fields. And we have good practices in our fields. And this is an example of a good practices in open access. The EGU in Europe, and we here at the EMS, in the European setting a little bit as well, has all their papers open access. It's not for free, of course. Open doesn't mean free. To publish there, it's still pretty pricey. AGU makes steps as well, but not as much as EGU yet. And of course, there's the great example from the physicists, where all their preprints are typically put on archive.org. And I guess I would encourage you to do that as well, to put that in repositories whenever possible. So these are good practices. We're not fully there, but we're working on it. There are also good practices in the data, I think, in our field. Our chairman works at Copernicus, and their climate data store is an excellent example of sharing data, which was just mentioned. Also the different MET services, like the KNMI Climate Explorer, the MET Office, they're sharing data. The way we deal with our metadata and our data formats, NetCDF is an example. The Seymour climate modeling conventions are an example as well. These are excellent examples of making it easier and facilitate the sharing of data and the interoperability of data. But to be honest, there's also a lot of data that's not shared. And that really hinders advances in our science, and in particular, lots of observational data is hard to get to. Sharing workflows is the next step. I guess our American colleagues are really, well, they show a good example there. Most of the NCAR codes, whether you think about the climate models of the WRF codes, is actually open source available. There's support with it. And the ID sort of behind it, if it's published and produced with public funding, it should be made available to the public. We make some advances in Europe as well. OpenIFS sounds open, but it's actually not that open. It's shared with the academia, but it's not fully open source yet. So I really hope that ECMWF does make advances to go there as well and to become more open on this. And we heard already about the pandemic and the importance of sharing data in the current crisis. And if you go to Zenodo, which is a place where you can easily share information, get a DOI on data, presentations, or papers, you can see how big of an impact this has on really making strides in the COVID research currently. So we have a good example at hand, and the climate crisis and the hazards we have from weather are not different in that. And the final point is whether our good practices is that this open science goes wider. It's not only about sharing among scientists, it's engaging the wider public, engaging even citizens. There's some excellent examples here. One again from Copernicus, from the Climate Change Service, where they really do capacity building. There's a mixed classroom from my own university where students and policymakers sit together and share information. There's a picture from a project that we run in the Mekong Delta in Vietnam, where really lots of information is shared with universities, with policymakers, with local authorities, which is really also transdisciplinary, if you like, so involving external stakeholders, up to really citizen science. iSpecs is an example where aerosols and air quality is measured from just your iPhone, as just an example. So there are many incentives to do open science, and these are the positive ones. You open up science to society. It really enables interdisciplinarity, and that's really the biggest questions in society that need science are interdisciplinary. It enhances your efficiency. You need to redo less of your work. It enhances transparency and equality and reproducibility. And actually, if you're a researcher, it enhances your visibility and impact. There have been studies, and they're published as well, on papers that are about similar subjects, but some of them published open access, some of them non-open access. And the open access studies are much better cited. So it increases your citation and career credit. Which doesn't mean that it's all easy, right? There's a bit of opposition, or quite a bit of opposition as well. One of them is that there's a significant investment if you do science, and there's an attachment to your data. I can feel that myself as well when I produce data. And this leads to data mining. The data is mine. Of course, if you think about it further than the licensing, the data is not yours actually. Often it's by your employer, owned by your employer. or even the funder of your research. There's a concern about inappropriate secondary use, which is a fair concern, but there are good examples as well where all the use of data, and think about the reanalysis data in our own field, has been such a good thing to our own field that we don't need to worry perhaps that much. There's a concern about being scooped, which we should really take seriously. And of course, there can be an unfair benefit, which is related to the scooped part, from shared research assets with little additional effort and input from, for instance, a co-author or so, which can be really frustrating to people. So how do we go forward? I think it's what Carlo said in the introduction. I'm very much convinced myself as well. This is the way forward. We need to share our information and science much more. So we should encourage people to do so. And institutions as well. But to be honest, the institutions are not always ready for this. I'm a dean at the university and I see how the different workflows and the ways we work are. So the rewards and incentives at the university or at institutions are not always matching with open science. And we should work on that we encourage sharing data, software workflows, and in a wider sense, communication, policy briefs, assistance, etc. The tooling should be there as well. These are often digital. And they are actually there, but they're not so clearly available and opened up to the wider community. And work needs to be done to do that. The next talk will show some examples, I guess, including the access to infrastructures. And there, the current developments on cloud infrastructures can really help. And finally, really, we should work on the increase of availability of open data, open journals, open access journals, but also software journals, data journals, to incentivize really and reward you from making your data available and make it citable. All of this requires a cultural and institutional change and challenge. And I really think we go forward. I see lots happening, and I hope this is really happening in our field very soon as well. And with that, I want to end my contribution. Thank you very much.
Thank you. It's an insightful talk. There are questions starting to come in. I mean, one of the advantages of the online version of a talk is that you can ask questions all the way through. You don't need to wait till the end, and so you can certainly do that. So there is a question from Dominique about open access. What measures should be put in place in order to fight against the predator journals that do not ensure a proper peer review?
Yeah, that's a very
guarantee of serious scientific work.
Yeah, that's a very good question. There are, of course, many open access journals that do not guarantee the quality. It's partly, of course, our own. The peer review should be well organized. So it's your also your own responsibility to do that. Of course, your work is being reviewed as well. Institutionally, this happens as external evaluations. And that external evaluation committee and the way they receive their protocols in terms of reference, they can put that into account. I also think there's a role for the learned societies and perhaps even this society as well to really advise and perhaps even certify. That may be one step too far to certify really, but really to look at what kind of steps on peer review do you require, and do these different journals really comply to that? So is there a sort of an audit on the peer review mechanism? If the peer review is open, actually that's sort of warranted already. That's a different discussion where it should be open, but I think these are routes to go forward to avoid that these predatory journals come up, and that that they come up we cannot avoid, but to avoid that these dominate our science and actually avoid scientific progress.
I do have a question myself. We can take the advantage of my position today, and it's related to the point you mentioned in relation to reproducibility of the results, and you know the Nature paper 2016 that you cited as a crisis there in reproducibility. And I was wondering whether in our sector there is an additional challenge in that, which is related to the size of the data set we have to deal with, and the fact that at times it's basically impossible to rerun the experiment or to reproduce byte to byte what is there. So how do you think we should tackle that specific challenge?
Well, I think it's a good question for our field in particular, where terabytes and petabytes go around, and it's not so easy to really fully redo the exact same study. The data, the provenance of the data should be, and of your results should be really clear. That's one thing. So the software behind it, how did you get to your results? That's not in a paper generally. There's no room for it, but the workflow can be shared and can be shared digitally with each other. So that can be checked. The other thing is what we can do is intermediate data. So the data that's derived from the original data, that can often be shared. And the third part is we don't need to replicate everything. It's about the knowledge behind it. So if you have other data and you can test the hypothesis that's basically being addressed in a paper with other data, that really brings science forward as well. So there are different lines that you can follow to do this. But regardless, I think we should make these terabytes and petabytes available anyway. And I think it is being done. And there the digital technology comes in place again. If we are capable of bringing the computing to the data, that's a technical way of approach, actually. Then we can actually do the reproducibility ourselves. And I think there's a role for the larger centers and the ones that host the data to also provide, perhaps in a cloud-like manner, some compute as well to people to really check the findings, but also then do a next step.
Shy, and now that we open the glass ceiling, now we have a flow of people coming in, but we need to keep the time. So I see the question. We'll try to tackle some of them at the end, but for the time being, let me thank you again, Wilco, and pass to the next speaker. Thank you, Wilco.
You're welcome. Thank you.
So our second panelist today is Peter Kalverla. He's a research software engineer at the Netherlands eScience Center since September 2019. Peter studied Earth and Environmental Science at the Wageningen University, receiving a master's degree specializing in meteorology in 2015. Peter obtained his PhD in energy meteorology from Wageningen University in 2019. In his current job, he collaborates with scientists to improve the quality and the reusability of research software. He's also the winner of the EMS Outstanding Poster Award in 2018 at the EMS in Budapest. Peter, the floor is yours.
Okay, so let me give you a quick introduction. I was asked after this really nice holistic view that we just had by Wilco, I was asked to present a little bit of a young scientist or early career scientist perspective on open science. And I thought it would be nice to make that really tangible, really practical, and to really show you what you can do in everyday research practice to make your research a bit more open. And during the preparation of this session, we thought it might be a nice idea to make a pre-recorded presentation, also because we are doing all this new online seminar stuff. And I thought it would be interesting to try that. So I have prepared a video for you in which I also show some screencasts of where I'm sharing some code. Yes, I don't have much more introduction to that. I'm just going to show the video. I think I saw some questions in the chat already about making this available afterwards. So I will try to make the video available afterwards as well through maybe the EMS YouTube channel or something like that. We'll see about that, but I'm going to try my best for that. But now let's just watch it. I was raised with the idea that research was this ever-growing pile of knowledge where everybody was building on the work of their predecessors. But as I was doing my PhD, I found out that everyday research practice can also feel like reinventing the wheel. And I think we can do better than that. Hello everyone, welcome to this video in which I will talk about open science and why I think sharing code is the single best thing we can do to improve the quality of science. My name is Peter Kalverla. I'm from the Netherlands. I studied meteorology in Wageningen University, and that's also where I did my PhD. And during that time I realized that there's a lot to learn, not just about the atmosphere, but also about the way in which we do research. And that's why after my PhD I moved to the eScience Center, because I wanted to learn all kinds of best practices that exist in research software development. And I'm really happy that today the EMS is organizing a seminar on open science, and that I get the opportunity to share some of the lessons I learned with you. So let's get started. Over the past few years, we've already seen a lot of good development in the context of open science. For example, open access publishing or the FAIR principles for research data management. But when you think about sharing code, that is really lacking behind. The main mode of communication in academia is still to peer-reviewed journal publications. But it's really hard to reproduce a complex data analysis from just the description in the paper. And then if you want to publish a paper, you have to go through this lengthy and thorough review process, but nobody ever looks at your code. And I think that's kind of weird, because that's what I spend most of my time on. Code is what produces all of those results that are published in those papers. And to think that that is not really checked or not really shared is actually a bit scary, right? There was this one time where I got an email from some random guy asking me like, "Hey Peter, I read your paper, it was very interesting. I'm doing something similar, also related to low-level jets, and I was hoping I could use your code. Could you please send it to me?" And I was like, "Yeah, sure. Well, wait, let's see. Then I'd have to..." And then I ended up sending him a completely modified version of my code where I polished everything, made it especially for him, spent quite a bit of time on that. And as I was sending the code, I had written an email and I was hovering with my mouse over this send button. It felt like publishing my diary. So I hope you all agree that it's a good idea to start sharing code, but now I want to talk about where to start. And for me, where to start is really about the quality of the code. Because in the beginning, I was really hesitant about sharing my code because I thought maybe the quality was not good or it contained bugs or whatever. And then I discovered that there are tools to automatically check this for you. Those are called linters. So to show you how that works, I dug up some old codes that I wrote during my PhD to analyze some IFS data. And if you scroll to this code, you can see that there's a couple of very long lines. 161, 162. Here I'm using Flake 8 to automatically check for code quality issues. And you can see indeed that it highlights these lines as being too long. Now I'm running AutoPep 8, which is an automatic formatter, and as you can see, it changed the spacing of those lines. And if I run Flake 8 again to check whether the errors are gone, well, there's a couple of them remaining that are apparently very hard to solve. You can also do this in Jupyter Notebooks. So in this notebook I have some plugins enabled. This one is Jupyter Lab Code Formatter, and I copied one of those functions with a very long line. And as you can see, I can also go to apply some formatters, and that works all very nice. So I would really recommend to install this because it's really useful and it can, with one click, improve the quality of your code. Next thing, I really quickly want to show you how to upload that code to GitHub if you've never done that before. So I'm making a repository here. I'm making a public one and I'm choosing a license. And then it's just a matter of create repository. This is it. So now there's a repository that contains a license and a README file. So now I'm cloning the Git repository from the web page to my local computer, and I'm copying that file ifs.py that contains the code. You can see it here now, and if I type git status, you can see that there's an untracked file called ifs.py, and now I use git add to stage it for commit, and I'm writing a commit message, first commit of the ifs script. These commit messages are very useful. If you type them nicely, you get a very nice overview of your project history. Git push then pushes that file to the server, and here you can see it's now added as well. Now let's say I wanted to make a change to this repository. For example, I noticed that the code quality was not great, so I'm gonna apply the YAP formatter. And if you type git status again, you can see that the file has changed. Now I'm gonna make a new branch using git checkout -b. The reason to do that is that you don't automatically overwrite the things that are master. So I'm writing the commit message again, apply YAV code formatter, pushing to a new branch. So if you go back to the GitHub repository now, you can see that it recognizes there's a new branch and I'm making a pull request from this branch. And the reason to do that is that in this way you facilitate code review. So this is super useful if you want to have a colleague or somebody else first look at your code before you add it to an existing code base. So let me just show you how we can use this interface. I think this is super nice. I would love to have something similar for reviewing journal publications, because you can just go line by line and you can always see changes and the history of the changes. You can also make suggestions. If you're finished reviewing the file, you can approve it or request changes, but in this case I'm just going to comment. And now you can see that I reviewed this file and you can do something about that, and if everybody's happy we can merge the pull request and then it gets added to the master branch, so the default code base. So finally I want to show an example of a repository that we work on. It's ESM for Earth System Model Validation, and I want to show some of the best practices that we implemented here. So for example, there is a Zenodo file, and then there is also a button which has a DOI in it at the top of the README file. And that will take you to the Zenodo page of this software. So you can actually cite this software in any publication or whatever builds on it. And that's of course super useful. If we go back to the homepage of the repository, you can see that there's a couple of badges on the top of the README file, and those are actually some quality assurances that you can use for code. You can see that there's a couple of pull requests, and if we click on one of them, scroll to the bottom, you can see that there's a couple of automated checks that are being done whenever you commit to this repository. And those just take a lot of work out of the reviewer's hands. The last thing I want to say about ESM is that a great example of people working together to try and make their code for their system model validation more uniform. It's always a better idea to join an existing project than to start your own. Now I realize that this can be a lot to take in, and not everybody is as passionate about code as I am. So my first advice would be to start small. Just share some code with a colleague and ask for feedback. Maybe, as a second advice, you can do some pair programming. So you sit together behind the same computer and just work together on some part of your code. It doesn't matter if your projects are completely different, because the next time you can do it the other way around. My third and final advice is to hire a dedicated research software engineer in every research group. And I know that's a big step, but I think not everybody can or wants to do all of this alone. And a dedicated research software engineer can help their colleagues implementing these practices and coordinating the research output of your group in terms of software repositories, etc. It is an investment and a big change, but I think it will definitely pay out. That was it. I hope you got inspired. Enjoy the rest of the day, and if you want to talk more about this, don't hesitate to get in touch. Cheers!
Thank you, Peter, for this presentation. And I mean, I think you are the only one who has used the new technology to the full extent. It's the first EMS talk with the background music. And I was rhythmically moving my head. So thank you very much for that. I think it's a part of innovation. We have a few questions. The first question comes from Gonzalo and is asking whether there are similar library to the one you have presented that can work in R and can help improve the code in R. I think you may be muted.
Oh, you're right. So, yeah, the advantage of making a pre-recorded presentation is that you can Google for answers while it is playing. So I had a quick look because I don't work with R usually. But there is a library called linter to find code quality things that you might want to look at. So lint-R, and then there is styler, I think. So style, and then with a big R, that can do some auto formatting. But I'm sure that if you Google for it, so like R formatter or styler or linter, then you will be able to find many more. They exist for really a lot of languages. So.
Thank you. Then there is a suggestion from Erasmus, and I think it's a suggestion for EMS as a whole, to give an annual prize to scholar in meteorology or climatology who are a good role model for open science and open data. I think it's an excellent idea. I don't know if you have a comment in relation to this suggestion.
Yeah, no, I completely agree. It's a great idea because, well, it really encourages people to, to actively take part in making their research more fair, and I think it's good to revive that in any way that we can actually. So yes, I think the EMS would be a great place for that.
And then finally, I would like to go back to a point that I think Wilco made before, because you mentioned, you presented how to share code and how to make it available. But I'm wondering whether the code is enough, whether the workflow is enough, or whether the reproducibility of the result also depends on your virtual environment, on the library you're using, or the ancillary data on your disk. And so whether an alternative could be, as Wilco was hinting to, the possibility of having a computer in cloud environment where you run in a stable setup.
Yes, you're right. So I completely agree with Wilco that using a shared compute environment is really useful. And of course, we already see that in climate science, where you have these ESGF nodes, which host a lot of data, and more they, for example, also host Jupyter Lab interfaces that can directly access those data and so on. So I think that's very nice. But in order to use that, you still need to be sharing the code. And then when it comes to sharing code, you mentioned reproducibility. And of course, there's multiple definitions even of reproducibility, and some are very strict and others are less strict. But I think in this case, it's really, you have to take small steps. So one step at a time and start sharing your code. And maybe if you really got that into your system, you can try sharing your compute environment as well. But I think you can take this step by step, and it's not a yes or no thing. So.
Thank you. Thank you again, Peter. And I would suggest to move on so that we can keep the timing, but we may be able to pick up some of these questions later on in the panel discussion. So the third panelist today is Gerhard Adrian, the president of the German Weather Service and elected president of WMO in 2019. After 19 years of collaboration within the World Meteorological Organization bodies and committees, Gerhard Adrian became president of WMO in June 2019. His main interest is to strengthen the WMO through a sustainable strategic plan and effective and efficient governance structures. Gerhard has served as the president of the WD since 2010. Without further ado, I leave you the floor. Gerhard, the floor is yours.
Yeah, thank you very much. And yeah, the title of my talk is very simple: Developments in Data Policy. I want to speak about, first of all, on the global perspective, on the WMO perspective. We have to remind that all weather forecasting, as well as climate and weather-related research, depends on a globally available, public available data set. And this is organized by the WMO, but by their regulations, and I want to explain this. But of course, I want to explain also the actual developments and I have to say that there are some threats for, let's say, the support for making data available on the global on the global scale. The support is decreasing for different reasons, and I want to try to explain this a little bit, what is behind. Yes, I want to start with to explain what WMO is. I have in my role, I hear a lot about WMO and how people think about WMO and what WMO is, and I think it's necessary to explain again to those have not direct access to WMO, to explain what WMO is, what is their role. Then, of course, the further development of the data policy developed in the WMO framework. I want to mention also what is going on in the European Union. It's very interesting, and I hope that this tendency, this development in Europe, may support others in other regions going in a similar way. Yeah. What is the WMO? Of course, I like very much this book, Basic Documents #1 of WMO. This is the convention of the WMO, and there's the Article 2 of the convention explaining the purposes of the organization. And there you find sentences like to facilitate worldwide cooperation in the establishment of networks or stations for making meteorological observations. That means to facilitate the necessary infrastructure for a global data set. Then, of course, data have to be exchanged, and therefore the next sentence is to promote the establishment and maintenance of systems for a rapid exchange of meteorological and related information. So to establish the necessary infrastructure and infrastructure for a data exchange, and of course you need standards, data formats, for instance, and that's the next sentence, to promote standardization of meteorological and related observations. This was formulated in the end of the 40s of last century, and I think these sentences are still valid up to date. The next issue is there's also some misunderstanding in some communities. I was quite often faced with a sentence that the WMO is an interest group of national meteorological services, which is not true. Who are the members of the World Meteorological Organization? And again, the convention says that any member of the United Nations having a meteorological service, so there's a combination between member of the United Nations and a meteorological service. And of course, there are few states still on which are not member of the United Nations, but they could also become member of the WMO if they are fully responsible for the conduct of its international relations and having a meteorological service. And approaching the convention of WMO means also that all members are obliged, or as it is written in Article 9, that all members shall do their utmost to implement the decisions of the World Meteorological Congress. So members are member states, and Congress decisions have to be implemented by governments. Governments should have a meteorological service, and of course, very often governments task their national meteorological service to implement decisions of Congress, but the basic responsibility is given to the governments of the member states. Yeah, in the system, a long-lasting discussion was going on, or has been going on the development of a data policy. That's begun in the WMO in the 90s of last century, and after at least 8 years of discussions, this famous resolution 40 of the 12th Congress was decided. And the WMO policy and practice for the exchange of meteorological and related data and products, including guidelines on the relationships in commercial meteorological activities. So we have here in the first resolution the relation between data policy and commercial meteorological activities, and it's going on up today. The next Congress, 4 years later, there was Resolution 25, exchange on hydrological data and products, and then in 2015, Resolution 60 of Congress 17, there's a WMO policy for the exchange of climate data and products. And if you look, and I want to explain in the following that the strongest resolution was the Resolution 40, and then the resolution following in time 25 and 60 are weaker and weaker. The last Congress it was basically not a decision of Congress, but a declaration of the delegates at Congress to build a community for weather, climate, and water actions together with the private sector. And meanwhile, this was a real decision of this Congress also to restart the discussion about to make a review of the existing data policy and to improve the data policy of WMO for the international exchange of data. Now, looking in more details, Resolution 40, there's a basic principle behind. Why should members, that means member states or governments, provide data on a free and unrestricted basis? It's written here, members shall provide on a free and unrestricted basis essential data. The definition of essential data will follow. Essential data which are necessary for the provision of services and support the protection of life and property and the well-being of all nations. That's a basic principle of the WMO. If you look to the original text, you find a footnote, and there in the footnote you find what we call today a license. Free and unrestricted means non-discriminatory and without any charge. And without charge means, in the context of this resolution, means at no more than the cost of reproduction and delivery without charge for the data and products themselves. That's a basic principle, and you find this also in EU regulations on data policy that's well accepted so far. But of course, that's not all data available. There are also the so-called additional data. Members should also provide the additional data and products which are required to sustain WMO programs and which might be of interest for most of you here in the audience. Members should provide to the research and education community for their non-commercial activities free and unrestricted access to all data and products exchanged under the WMO environment. This is Resolution 40. Looking to the definition of essential data, which are defined in an annex to this resolution, here you find where you find this resolution, the publication, the report of the 12th World Meteorological Congress. These data are 6 hourly surface synoptic data, all available in situ observation from the marine environment, all available aircraft reports, all available data from upper air sounding networks, and regional data and products which are distributed by the World Meteorological Centers and the regional specialized meteorological centers. These are the programs of WMO. World Meteorological Centers are, for instance, the global forecasting centers in Europe, ECMWF, Met Office, Meteoforce, or DWD. If you look here, 6 hourly synoptic data on a scale of order 200 kilometers, these are not our actual requirements looking to what we are doing today in operational meteorology. All available in situ observation from the marine environment. From my perspective, this does not really work. All available aircraft reports, no, the aircraft data are owned by the airlines mostly and are not free available. So there's some, it's a problem for WMO really to get the necessary support for the resolution. However, we have here the definition. Resolution 25 now from the following Congress, it's about hydrological data. Members shall provide on a free and unrestricted basis those hydrological data and products which are necessary for the provision of services in support of the protection of life and property and for the well-being of peoples. It's the same principle here as it was formulated 4 years before in the resolution 40, but what the contents of this data set has not been defined. There was a commitment is requested, but it's not a real definition as we have it in the resolution 40 for atmospheric data. Going to climate data and climate products, resolution 60, that's limited to a special program, the Global Framework of Climate Services. WMO was tasked by one of the world climate conferences to establish this global framework, and they have to enable everybody to take climate related climate decisions. That means the families, the governments, the global institutions to make decisions on special topics. That's topics like health, food security, water availability of drinking water, and so on. And there's written here, should be made accessible among members on a free and unrestricted basis. The definition of data is there, the GCOS essential climate variables, about more than 60 different variables meanwhile, but they should be made available. There is not a shall be made available. And urges members to provide additional GFCS relevant data products. And here you find for the first time a special sentence about funding mechanisms. So there's money behind that. So that's a development in the WMO so far. So as we have seen in the resolution 60, there is a relation between data acquisition, business models, and data policies. And there we are faced with a new, during the last 10 years, we are faced with a new development coming very much from the space industry. The traditional approach, a National Meteorological Service, builds and operates the observing system. This is financed by the state budget. The National Meteorological Service fulfills the obligation of its government and distributes its contribution to the essential data set under a free and open conditions. That's the traditional approach, how the resolution 40 worked for many years. Now, a new approach is that a commercial service provider builds and operates the observing system. And this is financed, of course, by selling data, by revenues from data selling. And users buy the data by the provider, but the providers may not have an interest to offer a license allowing a free and open distribution of those data. And this is the actual development we are faced with. We have this development, for instance, in Earth observation data, especially also, meanwhile, also for meteorological data. And that's an issue, of course, for WMO, but I guess also for all of us. Therefore, the delegates of the last Congress, they decided declaration. Here's the title of the declaration: Building Community for Weather, Climate and Water Actions. And there it's more or less, it's an invitation to the private sector to contribute to the system. And there's written that the heterogeneous business models of the diverse stakeholders and differing legislative frameworks of the members have to be recognized. And of course, there's a persistent capacity gap between developed and developing countries. So there is also, of course, an issue of financing the system, that especially in developing countries, there very much are the same experience we had before during my presentation with that it flips here. Sorry. Between so there is a gap, meanwhile also a data gap if you look, for instance, to the southern hemisphere, especially in many developing and least developed countries. Yeah, therefore WMO is now trying to organize, let's say, money streams, especially those coming from the global developing banks like the World Bank and others. They established they try to coordinate their activities by establishing a systematic observations financing facility. That the program is called SOF. The objective is to close gaps in the global observing system. And the expectation, or let's say what we expect from the international development banks, is that they are thinking about possibilities to provide a sustainable financing, not only for making such data available, not only for limited projects, but on a sustainable basis. They need support, they need consultants how to organize this, and there WMO established a country support initiative to leverage available competences from member states. The idea is, for instance, that experts from the Met Office or Météo France or DWD are going or give advice or consultants to developing projects of the international development banks. And the first and a new data set has been defined in a more modern version of this Annex 1 of the Resolution 40. That's the Global Basic Observing System, the so-called GBON. The idea is to improve the definition of this essential data set, especially to improve the available information needed for global weather forecasting and climate simulation. Yeah, now what is going on? Further development of Resolution 40. There's a study group now has been established, and for the further development of this Resolution 40, there are some basic senses or basic issues are known. They want to keep the structure of this essential and additional data. And the essential data also in the future shall be subject to a free and unrestricted exchange. Which might be interesting for you. The concepts will be discussed on a WMO data conference. It is an open conference in November, and it will be also a virtual conference. So that I hope that many of you could, or some of you could attend this meeting. So this was the global development. That means let's say the support for a global data set exchanged on a free and open basis. I have to say it's decreasing, unfortunately, for different regions. It's very much connected, of course, with the finance situations in different countries. But of course, also a felt composition between the private sector and the public sector. Here in Europe, I hope the situation will improve. There we have this directive on open data and reuse for public sector. In this directive, high value data sets are defined, or and these high value data sets shall be free of charge for the user. And meteorology is especially mentioned there. The Commission has been tasked or is delegated to identify such specific high value data set after consultations. These consultations are going on. Last week I was quite pessimistic on what is going on meteorological data. My concern has been that let's say, the data providers or the data users try to hide themselves, and it was only very small part of the available information identified as of being of high value. Meanwhile, the consultations is going on, and the situation hopefully is improving. But of course, there's a policy objective behind. If you see it here, high-value data sets, which are data sets which are associated with important benefits for society, for the environment and economy, and to support economic developments. Sustainability for the creation of value-added services, application, and new high-quality and decent jobs. We have to remind at the beginning of this session, it was Copernicus was mentioned for an example for free and open data policy. Yes, but we have to keep in mind that this is paid by the European Union. So the European Union makes these data free available at the end, finance the availability of the data. Okay. From my perspective, the big chance we have with open data and meteorological service, there will be a big change from my perspective. Also for us, as coming from myself and from my organization as a National Meteorological Service in Germany. Big data and artificial intelligence together with open data provide the development of new services for new fields of applications. So we have new actors also in the meteorological enterprise, commercial and non-commercial. The so-called hyperscalers, the data economy, or examples we are faced with aviation and space industry, agriculture, chemical industry, and much more. So it might be a disruptive development for the existing meteorological enterprise. So our world may change in the future quite fast. I'm convinced. So thank you very much for your interest. And back to the,
Thank you, Gerhard, for an excellent talk. And a talk that certainly has triggered a lot of curiosity and a lot of questions from the audience. So I'll do my best to navigate to the many questions, and I'll probably start from a question from Anna asking, open science is also about providing open data set. How would this work with this new business model, which is also related? I don't know if I can put two questions on the screen, possibly not. But it's also related to the question from Dominique and what measures should be put in place in order to avoid that a few major players develop a monopolistic situation in the area of observation or specific services. So
I don't have an answer to this so far. I mean, in Europe, if you look, there's a very nice, from my perspective, very nice. The EU has a very nice data strategy, and they are trying to sort out the relation between public institutions, public data providers, the relation between public and commercial data providers, and the relation between commercial data providers. And this open data directive is now a directive for the relation between the public sector and the commercial sector, and the governments. It's important. The governments have to implement this directive until summer next year. So it could be a very quick process going in this direction, hopefully, in Europe. I mean, that's very much how the problem on the globe, on the global perspective, is very much connected with the role of public institutions, and also how the public institutions in the different states, member states of WMO. Public institutions here in Europe are most of the academic sector, and as well as, for instance, the National Meteorological Service. This is quite easily controlled, let's say, by the national legislation. On the global scale, it's completely different. There are many, I know many meteorological services, national meteorological service, which we would recognize as a public institution. They are commercial. They belong to the state, but they have to finance themselves. So the issue is really how to, and that's the discussion which is going on, how to get more interest of the private sector in making data free available. I think that's the way we are trying to go. But how to achieve this, that's the discussion is going on. And I mentioned also this open data conference of WMO. This is one of the topics there.
Thank you. The second question I would like to pick is this question from Bert, and it's about, it's not just open data, there are all these principles of open science that Wilco touched on in his talk. And I guess the question is, what is the plan for WMO to look at open software?
Yes, of course, open science is an issue in the WMO discussion, but in the moment we concentrate our discussion on open data. I can tell you that we have, I'm the director of the German Weather Service, one of these world meteorological centers, meanwhile, and we operate a global forecasting system, and which is commonly developed with the academic sector in Germany, especially. It's a cooperation between us and the Max Planck Institute for Meteorology in Hamburg and one of the Helmholtz institutions. And of course, their request is to make the data free available. We are a governmental institution. We are not allowed to give something where the government has spent money into it for free. However, we are working on a license model to enable, which will help us hopefully. So it's a very difficult question, let's say, for only in the example of one member state. The big issue for us as an operational center, open data, and that's a question maybe also for the panelists here. Open data sounds nice, but of course the codes we have available, ECMWF has available. I'm the national German delegate in ECMWF Council. How to maintain the system? Who is deciding what comes from outside into the code? What will be? I mean, the code will be. That's the basic idea from open science, as we have heard, and open software that we gain from this. But how to test this in an operational environment where this code has to be run several hundred times per day without any interruptions? So there are, let's say, a lot of technical questions from our perspective, but I should stop here. That's not the real topic here.
Thank you. I would suggest to move into the panel discussion. So I will invite the other panelists to join us. And while we wait for them to come in, let me just remind you that the recording of the session will be available afterwards. So if you want to listen or look at some of the slides, you will be able to do it later on. I think we can't have three cameras on, so I will chair from behind, so to speak, so that Peter can. Yeah, and maybe we can go back. I mean, it's really difficult to navigate. There are so many really excellent questions. But there is a question, and I guess it's a question that was originally asked to Wilco, but is probably a bit wider. And it's very much related to the discussion we were having now on the business model and the data, and coming from Adrian. And it's sort of highlighting the fact that innovation is often related to some temporary exclusivity of data. So in a sense, we see that in the pharmaceutical industry, for instance. We see that in other industry as well, where you invest in a direction, you want to do it as a private organization to get a benefit out of that exclusivity. So how do we reconcile this with the need for an open science, especially in this moment where it's so evident that sharing the data and sharing the science publicly represents a big advantage for society? Maybe Wilco, you can elaborate on that, and then we can pass it to other panelists.
Yeah, thank you, Carlo, and thanks to the previous speakers. That's excellent, actually, to have these three perspectives. And admittedly, to Gerhard, I took a bit of a science approach, which sometimes is naive in terms of the operational and the governance aspects that come about. And I know this very well because I was preparing the deal with a big publisher, Elsevier, for all Dutch universities, and this has similar characteristics. on this aspect, it could be a step in between. It's not such a bad idea and it works pretty well in different part of geosciences in my faculty to have half a year exclusivity on the data, to be able to publish your results. But once you publish it, that the data becomes available. Personally, I don't think there's that much of an issue to make it available earlier. Mostly from a science perspective, you have so much advantage and to already be involved in the setting up of the experiment, whether it's observational or a simulation experiment, that I've never seen people really scooping data in that sense and scooping ideas. But it may be an intermediate way to alleviate some concerns that people have about not sharing by being scooped, or that inappropriate use of data is being done. And it works in physics in the same way. So it may be a good intermediate solution.
I don't know if Gerhard or Peter want to intercept the discussion at this point.
Yeah, no, only, I mean, it sounds like advertisement, but yes, I'm very happy. I mean, following also the EU regulations, Inspire and PSI directive, and meanwhile the Open Data Directive, my government or the German Parliament has changed our law on DWD, and meanwhile we make all our geo-related data free available. We are not able really to use the modern technology in the moment we are working on that, but that means we make data of about something between 2 and 3 terabytes, partly updated every 5 minutes, free available to the public without any control who is using this data. There's no registration. We don't know who is using these data sets, but I think that was a decision of the German Parliament going in the right way, and this is one of the examples. And I make a lot of advertisement also to my colleagues in the other national meteorological service. We have to work, we as a public institution, we have to work with our governments in this direction.
Yeah.
There's a second aspect, perhaps, Carlo, I didn't mention, is that to change the incentives or to change the reward system on this, right? If the reward is making the data available as a scientist as well, this can be through data publications, citations, etc., as well on data, then we change the system itself. So then you may be incentivized to share your data immediately, or your software, or your workflow in general. Currently, that's slowly happening, right? The different open science principles on rewarding scientists, rewarding institutions, that if they follow the policy that Gerhard just said, that actually that's a plus in their evaluation, also in the scientific evaluation of that institution.
Yes, and I think we are seeing a movement towards open data. Germany for sure, but most of the Nordic country, the Netherlands, I think it's a general movement, and so it's good that we also reflect on the mechanism to reward and ensure that these pushes towards open data are actually something worth embracing for the scientists. So I would like to pick on this point. I would like to pick on this question from Mike, and it's partly related to the discussion. So in a sense, at the moment there are competing demands on their time for scientists. So you have to do the science, you have to do the code development. We have seen what does it take from Peter in terms of polishing your code, or presenting it, and so on, preparing it, and then sharing. These are a significant effort that science needs to face. Do you think we should change what the scientist is, or the support function to the scientist? We should change their work system. How can we make the life easier for people? Maybe Peter, you can start on that. Peter, you can start on that, and then we can share it with the others.
Yes, sure. No, I think you already hinted in the right direction. So first of all, I would like to say that the way we currently do our work is also not the most efficient way, right? Because if you want to try something that someone else has already done, you need to start from scratch, as I said, basically. So it also could give you an advantage if we can get this into our system. But I really understand the perspective from the scientists that say, okay, first we needed to make the publications open access, and now we also need to polish all this code and do code review, and it's just another thing on your plate. And that's, of course, not what we want. So therefore, I do think indeed that it would be really good well, as I said, one solution would be to hire dedicated research software engineers in academic groups, for example, because, well, we now have a model where every scientist needs to be able to do everything, but I think it might be better to have some sort of specialization where one person can be more dedicated to sharing the code, and they could help their colleagues, and then the scientists will actually benefit from it because they have to eventually spend less time on making their code work. So I really think that would be a good direction to move forward. But I'm curious as to what the other speakers think.
Wilco?
Yeah, I think that indeed this is a way forward just for efficiency of science. But again, just alluding to the previous part that I talked about, if we think about both the reproducibility of the sort of trust in our science, and also think about the efficiency of science from an institutional management point of view, it means changing the incentives and changing the reward system a little bit. At least in my country, it has a bit gone probably too far to rewarding excellence only in terms of publications and high-end grants, very competitive grants. And that didn't really perhaps make science overall better. And that means there's a role for the numeration, for the way we promote people, etc., and we value the other aspects just as much. And that's a broader cultural change that I alluded to at the end that we need to bring into the system. That's very hard as well. It needs to go stepwise because the system, everybody also preparing for a scientific career is geared up for having these excellent publications, etc. So there's work to do.
Yeah. Unless, Gerhard, you had a specific point on this one, I would like to go back to the data because there are several questions related to the data and the data sharing and the business model associated with that. Would that be okay, Gerhard?
Yep.
So there's one question from Robert about sharing data with commercial weather company. And sort of saying that it's often one way, the data is shared in one direction, but the opposite doesn't quite happen. And I appreciate it. Unfortunately, I cannot have two questions at the same time, but I would like to put this one in the context of another question coming from Stefan, that on decreasing support for global exchange of essential data, what is the alternative proposed by those supporting commercialization of data exchange? Under which business model should commercialization lead to higher availability and exchange of data? So there's clearly a relationship between the two. Given that you brought the WMO perspective on this and this change in model, maybe you can start answering.
Yeah, there are two directions which have been discussed in let's say in the recent 2 or 3 years. One is, of course, is to find it to get more money from, let's say, from the public sector. I mentioned the role of the international development banks. This is public money basically to finance the system. The other discussion was how to share data and get money is simply on the one by selling data, but to make the prices for one data set or for a single datum dependent, for instance, on the GNI of the state where the customer comes from. So that means that a scientist from the US has to pay most, from China the second most, and then Japan and somewhere Germany, and the data users in a developing country have to pay more or less nothing. And the data is used to support or to improve the observing system. That wasn't. This kind of business models have been discussed so far. I do not know in which direction it is going, but in the moment what we recognize that we don't have enough money in the system. On the other side, of course, open data enables completely new applications of these data. I mean, when I studied meteorology 35 years ago, I think the traditional outcome of a National Meteorological Service was a weather report. Today, with let's say with big data, artificial intelligence, they come out completely new services. Where we as a public institution do not have any competence, so that the usage of our data, our interest is that our data are used as maximum as possible, is done by a new kind of private sector, and that means they gain money and of course taxes, and that's, from my understanding, if you look to the Open Data Directive of the EU, that's behind this Open Data Directive, this kind of policy to bring data together by make them open to enable the development of a new economy, I think, or to support the economy. That's what the European approach. Of course, this will not work in the developing world in the moment, but at least we should go forward in Europe, at least in this direction. It's not a clear answer, I know.
Well, I think it's difficult to give a very clear answer on this matter. There are a lot of competing aspects that needs to be taken into account. But it was definitely useful to have the WMO perspective on the matter. Wilco, do you want to?
No, I agree with Gerhard that the way we shouldn't fear the commercial sector, but there needs some regulation to be on it if you want to work with public information, and that regulation is not there yet. The Open Directive is a good way forward. I agree. The new services that only stimulates innovation, so we shouldn't stop that. But that also means that the data they produce, the commercial sector, should also be made available to the public. So there a business model needs to be found that makes that work, but also that there is some enforcement, some legislation on top of that, which Europe now tries to avoid that all the data is hidden. The hyperscalers, as Gerhard mentioned, then show that this is possible. It's possible to share data and services for free as long as they make more money on other kinds of services. And one may fear that a little bit, but there's public interest for innovation as well, and for the different nations the same. If I may make the little example on what I just alluded to, the publishers in the academic sector misused their position so far. The profit line of Elsevier has been 37%, which is a margin which is ridiculous. There's no other sector almost where this is so much, which means we let that happen as a public sector. And currently, the way we discuss with publishers on scientific information, and you may perhaps translate it also to data, is to put some guiding public principles on top of it, which are also guiding the contracts that we have. And those public principles could include sharing the data, and then have a fair price for that, because it's never for free. I mean, there were some questions underway as well that this is expensive. Yes, it is expensive. And Gerhard said, well, there's not enough money in the system. I'm actually convinced that there is enough money, but it's not in the system currently. And you need the commercial sector to get that into the system. It's not all coming from the public sector anymore. And to avoid that, we get into this, almost like what's happened with Apple and Facebook discussing with the European Commission as an afterthought. It's very good that WMO thinks about this now and can do this beforehand. I'm a bit worried that in Europe we go quite quick on this in one direction, and other parts of the world are either leaning back a little bit and looking at what's going to happen, or find another direction. So that's it's going to be exciting for the near future in that perspective.
But I think what you were mentioning is quite important. So the private sector is essential in terms of bringing money to the system, but there is also the need of finding a solution for this asymmetry that some of the questions were referring to, whereby the public body provide data effectively for everyone to play with in an open and free way, and the private players do not play the same game. So how do we ensure that the system actually works, that we can ingest or input the funding from the private sector while maintaining some sort of level playing field?
I think actually it can be done if their business model is based on the services rather than the data itself. But that's not so clear yet. But if that's the business model that they do have, then I think it can work. But that needs quite a bit of discussion with the commercial sector as well, which I wonder if you do that sufficiently.
Indeed. I know we are taking quite a bit of time. I would like to pick another question that is related to the discussion, but has a different characterization. And it's related to the metadata that is coming from Erasmus. And it's all nice and good to discuss about the sharing of the data, but this becomes nearly impossible if we don't ensure that there is a common approach to the metadata, to the provenance, and so on and so forth. So, what sort of effort is being put into that now, and what else needs to get into it in order to facilitate this exchange of data? I don't know, maybe Peter, or Peter rather, you can pick it up yourself, and then we can pass it to Wilco and Gerhard.
Yeah, so I think we're far ahead with sharing metadata in our field. So we now have settled on this NetSDF file convention, which supports metadata by default. There's also, so for example, if you have data repositories like Zenodo, you can add a lot of metadata there as well. And if you look at the FAIR principles for research data management, then this is quite well described what kind of information you should add. In climate science, there's a lot of conventions on ontologies or something like that as well. Like, how do you name your variables? Which kind of how do you name your coordinate system? Whatever. So there's already quite a lot of conventions on that, and I think we're really in the right direction there. So, well, with respect to whether code is also metadata that's necessary to read the data, I'm not sure about that, because if the metadata or if the data format is really interoperable, then you should be able to read it with some other whatever generic software that's suitable. But we should be sharing code, of course. But I'm not sure if it's part of the metadata. You could point to the code, like this can be used.
I'd be worried by your comment. There are many standards on metadata, and many conventions. Because if you have many conventions, it's like having none. In a sense, if you want to ensure a good exchange, then you want to be sure that there is a standard and is accepted by everyone, and is unambiguous and can really be used across different data sources. And I don't think we are quite there yet. So I feel that you're right. We're probably better than in other communities in the weather and climate community. But nevertheless, I don't think we still have a system that is sufficiently robust to really ensure an exchange of data, especially if you consider different data sources at its origin. I don't know, Wilco, how do you see that?
True, of course. So when I meant we have a lot of metadata conventions, I was referring to we also have quite comprehensive conventions already. But of course, if we have different sets of conventions, that's not the way we want to go. So yeah. I guess this also needs to be evolved, because you cannot think what the correct set of conventions is ahead of time. You need to find out, and therefore it's also good that there is some variety in what's there. But well, we should keep that an active discussion, like what should be the correct standards.
This is a pretty tough one, right? I recall, and I always sound old a little bit, that we had a European project called Metaphor. Which led to a sort of a metadata standard, which everybody it's like this Christmas tree, right? These features came in and more and more and more and more. What it actually lacked was a good ontology, and what one can discuss on ontologies forever in this kind of field. But still, I think one can make use of, even if there are different standards around. If you have a good ontology, if you work with semantic technologies, etc., there are ways to cope with it. Nevertheless, it's true what the question, I think it was from Rasmus, was about, that it's sharing metadata is equally important, and maybe the easiest place first, right, before starting to share all the data there is, because that's just so much around that's pretty hard. But if we don't have some standards of exchanging or some protocols of exchanging this information, then we're lost. So even though the standard of the data itself may be different, but we need to be able to make it, the minimum is to make it machine readable. And that is really the bare minimum.
Some advertisement for WMO. We have the WMO information system. That's a global metadata catalog for all data which are exchanged or made available. It's not only a description of data sets, but it's also a complete, mostly complete catalog of available data, also on historical data, of course, depending on the information which is provided by the data owner. But this system is growing, and it is an open system. So also the academic sector could use this system. And I know it here from my surrounding, that means from the German larger research institution, which provide data for the whole community. Those data could be also, or the metadata could be found also in this WMO information system.
Thank you, Gerhard. There's still a question out there, but I feel we are somehow losing a bit of steam after an hour and a half of teleconference. And probably is a good point to wrap up this excellent discussion. I really enjoyed the presentation. I enjoyed the discussion. This is clearly a very important point. And I don't think it can be covered in just an hour and a half, but in this hour and a half, I think we've done quite a bit in looking at different aspects of open science. So I would like to thank all our panelists. In some cases, we'll be able to come back to you with a direct response via email if we haven't managed to respond to you already. And as I mentioned before, the recording of the event will be available for you to watch should you be interested. So once more, thank you all. Thank you very much for being here, and see you next time.